All right, so today's a review day. We're going to start off here with graphing on bell work. We are doing a little bit different. We're graphing cotangent, and we want to graph it from negative 4 pi to 8 pi. So, like always, start off with amplitude, period length, vertical shift, and horizontal shift. Eventually, we're going to talk about domain and range. So just listing those out probably doesn't hurt you anyway, so you don't forget. Amplitude, that's 3. That's easy. Period length, what's our base period length on a cotangent graph? We're going to start off with pi because we're going to the beach. We're going tanning. We're eating less pi. So only 1 pi. Megan C, what do I need to multiply that by? 4. We got this 1/4 here, so she's going to multiply by the reciprocal. We get 4 pi. There's no vertical shift. There's no horizontal shift. Questions to there? Make our graph knowing that I'm going between 4 pi and 8 pi. I'm going to make a pretty long axis here. And give me a little bit of space, more space here on the back side than normal. Making my 4 hash marks. So 1, 2, 3, 4. What should I label that 4th hash mark as? 4 pi, because that's my period length. That one's 4 pi. This one's 2 pi, 1 pi, 3 pi. Let's graph cotangent and then go back and kind of worry about the extra period or the extra spacing there. Okay, so actually I lied. Let's just do the whole thing. So that's 4 pi. 1. How many more hash marks do I need to make after 4 pi? 4, because I need to get to 8 pi. So 1, 2, 3, 4. That's 8 pi. You could label the others, but I'm confident in your abilities. Go left 4 as well, because I need to go left 4 pi. That's going to be negative 4 pi as well. Cool. We're graphing cotangent. So if I'm graphing cotangent, what is going to happen here on the y-axis? Is it a vertex point or is it an asymptote? Asymptote right here. Okay, cotangent starts with an asymptote. So I've got an asymptote right there. Armand, when's my next asymptote going to happen? 4 pi, because it's a period length. So that's how long it takes for me to get from one asymptote to the next. And so my next one's over here at 4 pi. Cool. Then 8 pi. And then negative 4 pi. I could have made this one harder. Instead of cotangent, if I had made this tangent between 4 pi and 8 pi, you'd have had to think a little bit more. That's okay. There's my graph. Then I'm making my dot. So obviously, if that's the 2 asymptote lines, my middle point's going to go in between those two. In between those 2 asymptote lines. As I go to pi, show me with your fingers, what is your y value going to be at pi? Y3 here, Megan K. Good. We're going up first, and then we've got that amplitude of 3. The combination of those 2 things is why I'm going to be up here at 3 there. So I'm going to go ahead and label that 3. So that means at 3 pi, I'm going to be down here at negative 3. Wonderful. And then do your best to graph yourself a little tangent in there. Talk with your neighbor and discuss what is your domain and range based on this graph. Go. Here we go. We're doing domain. All real numbers here on domain. Ella, what can x not be? Good. 4 pi, because that's when my first asymptote is. You could say 0 if you wanted to, but one happens at 4 pi, and then it's going to keep repeating every 4 pi. So 4 pi, 8 pi, 6 pi, negative 4 pi, so 4 pi n is a great answer there. What's my range going to be, everybody? All real numbers, because it's an arrow going up and down forever and ever, so it's all real numbers. Questions on bell work? Not too bad. Getting our feet wet a little bit. All right, so today we are going to do a little bit just of you looking at the board a little bit more than normal. Kind of like a whiteboard, but you don't really need whiteboards. You're going to talk with your neighbor quite a bit. So if you are by yourself, kind of talking to you, you go that way for me, and then you go that way. You two talk. Yeah, okay. So a couple different games. Game number 1 is, which one does not belong? I've got a graph up here. It is a sine cosine looking wave. I got 5 different equations. Which one does not belong? You're going to talk with your neighbor here. It's going to take you a little bit of time, but kind of work your way through and figure out which one does not belong. I'm going to call on you to see what's going on. Everybody understand what you're doing? Go. So as we're looking at this, we're trying to figure out which one does not belong. Lydia, what is one graph up here that you think does not or that does belong? What's one that you're confident is the same as that graph? The first one. Okay, so let's talk through that a little bit. If we think it's the first one, we've got 2 sine x plus pi over 2 minus 1. Obviously, the 2 and the negative 1 were good. That's the amplitude midline. So we're talking down here at negative 1. If it's sine, what is that plus pi over 2 going to do to my graph? Move it to the left. So now I'm talking about right here. And a sine curve starts top, middle, or bottom? Middle. Starts in the middle and then goes up. So that one should work. Let's turn it on. Boom. It traces it. We're good. First one's good. Okay. Another one here. Kara, what's another one that you think definitely belongs here? The fourth one. Okay, so we're looking at the fourth one. Similar. So we've got this negative 1. We got that negative 2. Which direction is that minus pi over 2 going to take me? To the left, right? Because I've got 2 different negatives here. I got this negative and that negative. So it is going to take me to the left. What is this negative going to do to my graph? Nothing, because they cancel out. Good answer. I've got this negative here and that negative there. We're flipping it twice. So we're going left pi over 2, and it's a regular graph. So it's going to be the same thing we did on the last one. Boom. We're good. We're 2 for 2. Okay. Let's do another one. Matthew, what's another one that you think is going to fit?
We'll say 5.
5. Okay. So if we got to 5, which direction is that minus 5 pi going to take me? It's going to take me left 5 pi. So I'm going to zoom out, move over here a little bit just so we can see it. But left 5 pi. What is this negative going to do to my graph? Nothing. But this negative right here is going to do what to it? Flip it. And so at negative 5 pi, we should be starting at the bottom because we said it was flipped. Let's see. Boom. It's in there. The green one kind of overpowers it. But yeah, it's in there. Okay, good. We got all of them. We've got one left to go. One of them that does not fit. Anyone confident in which one does not fit here? Which one is the bad one? 3, 2. Ooh, we're going back and forth. All right, let's look. I think 2 is the easier one, so let's just talk through 2. Negative 2 cosine negative x minus 1. So I'm down here at negative 1. What is this negative going to do to my graph? Nothing. So what is this negative going to do? Everything. Flip it. Okay, it's going to flip it. So where would a cosine graph normally start? At the top, but it's negative, so it's going to start at the bottom. So this one looks like the one that's not going to work. It didn't. Okay, we flipped it upside down. So that one's going to be the one that does not fit. This one is good. The plus pi over 2 would take me to the right since I have a double negative in there. So I go to the right 2 pi. It's not going to actually flip it, and it's a cosine graph, so it should start at the top. And it does. It's up there. It didn't. You can't see it, so that means it works. Kind of makes sense, that game? Let's play it again. Here we go. Same idea. This time we're working with a tangent cotangent graph. Figure out which one of those does not work. Here we go. Which one of these does not belong? So let's find which ones do belong. Kate, what do you think? Which one are you confident in? The first one. We got a tangent x. The minus 1 takes us down. What's going to happen in the middle of a tangent graph? The vertex. We got our middle point right there. Boom. Yeah, let's turn it on, see if it works. We're good. It matched. All right, we're good. We're 1 for 1. Sam, what's another one you got for us? The second one, this one right here. So we've got minus pi over 2. What's that minus pi over 2 going to do to my graph? Shift it to the right. And so what normally happens at the start of a cotangent graph? An asymptote. So we have it, we shift to the right, we should have an asymptote. Looks like we do. A cotangent graph normally starts up and goes down, but this one is flipped, so it's starting down and going up. So that one looks good to me. Turn it on, boom. We're 2 for 2. Another one. What else are we confident in? Max, what's another one you feel like you know? The third one. Okay, that's a tangent graph. So we're going to start in the middle. What is this negative right here going to do to my graph? It's going to flip it horizontally, and what's this one going to do? And yeah, they're really both become flip vertically because of what we can do with them, because it's an odd graph, and so it should match because it's the same as this one, just a negated flip. We're good. We're 3 for 3. Anyone confident on which one of these is the right one? The one that's correct. What do you think, Matthew? All right, so let's look at number 4 here. Cotangent negative x minus pi over 2. Which way is this minus pi over 2 going to do to my, what's that going to do to my graph? Move me left because it's minus and a negative. So I go left to pi over 2. It's a cotangent graph. So what's going to happen at the start of a cotangent graph? An asymptote line, which is what we got there. And this negative is going to do what to it? Flip it. So instead of starting up and going down, we're going to start down and go up. We got it. You think the last one's right too? Let's check. The last one's right too. I'm an awful human being. Imagine that. Who would have thought that I'm just a mean person and they all worked? That's crazy. Let's look at the last one. Plus 3 pi over 2. That's going to move me to the right because it's minus and a plus. So I'm going to have an asymptote there, and then the negative's going to flip me. Yeah, they all worked. I'm a jerk. Deal with it. We good with that game? You don't like that game? All right, let's play a new game then. All right, everybody loves the list game, so let's play the list game. Your job is to go around the room one time without repeating an answer. Your job at your table is to write an equation for that graph. Without repeating one, you're trying to write one, so start brainstorming some ideas. See what you can do. Let's see what we can do. Can we make it all the way around the room with a new equation each time? See what we can do. First one, who wants to start us off? Oh, okay. Matthew started first because he got his hand up first. What do you want, Matthew? Negative 2 sine x. And you didn't really mean sine. You meant what? Yeah, exactly. That's what you said. It was cosecant there. We did want the sine graph, but we got that one. Boom. We got the easy one out the way. It is a secant graph. We're good. Next one. What you guys got? X plus pi over 2. Look at it. We're good to go there. It's a secant graph, so we're going with cosine. Plus pi over 2 is going to move me left, and cosine starts at the top. So we're good. We got a second one. Aaron and Ella, what you guys got?
Negative 2 cosecant x plus 68 pi.
Plus 68 pi. I like it. We know that the graph repeats every 2 pi, so we could get pretty creative and throw a whole lot of numbers in there, but no one else has 68 pi, I'm guessing. Good job. So we're just going to start again here in the middle and go down. Let's try to avoid those in the future, but I like it anyways. In the back, what you got for us? X minus pi over 2. We're so close. What should I do with that? Oh, 3 pi over 2. Yep, there we go. Okay, we're good. You're good. Minus 3 pi over 2. We are graphing from our seats as we look at the board. I understand the confusion, but minus 3 pi over 2, that's going to take me to the right. 3 pi over 2, it's a secant graph. So that means it's cosine. It's got to start at the top. Boom, that's where I would want to be. Max's group, what you got for us?
2 cosecant x plus pi.
Boom. Good. Same as this first one, but the first one's flipped. This one we just shifted to the left pi. And so we're going to start here in the middle and then go up because it's a sine graph. Boom, we touch them all. Good. Last one. What you guys got?
Wait, so we can't just add 2 pi?
I'd rather you not. Give me something else. You can, but.
Negative 2 secant x minus pi over 2.
Boom. We matched it up there. Minus pi over 2. We go to the right pi over 2. It's negative, so we start at the bottom. We go from there. I didn't call on you guys yet, did I? Oh, you thought I was going to just miss you.
We also said, well, we didn't say negative 2 cosecant x minus 400 pi.
X minus 400 pi. Yeah. All right. We'll count it. Well, at least we went the other direction. They went plus. You guys went minus. Way different. Nice work. Good. That's impressive. In terms of being able to do that, obviously you're at your table and you're trying to graph. It's funky, but the idea that there's a whole bunch of different graphs for each thing is kind of the thing or a different equation for the same graph is kind of the point I wanted to make. Okay. I passed out a 6-graph review. Okay. So we've dealt with equations. The other aspect is being able to graph it. Okay. So each one, you've got one of each type that we know how to do. You've got some time here in class. Your job for tomorrow is to get that complete. Okay, domain and range for each one as well, but you're trying to graph each one for me.